Good day, everyone. So today I'll be discussing about low water and controller failures, focusing on safety and emergency procedure for low pressure and high pressure boiler. So let's start. Our learning outcomes explain the emergency procedures for low water level and controller failure. Our content today is number one, low water level emergencies. Number two, is controller failure management. Number three is boiler pressure emergencies. So let's start with low water level emergencies. So our causes and detection methods. Low water level causes inadequate water supply, leaks, excessive steam demand, improper feed water control, or pump failures, which can lead to dangerous low water condition. All of this causes All of these causes reduce the water level below the sake point. And when water becomes too low, the tubes are no longer submerged, and they heat up. I mean, rapidly. This can cause warping, tube melting, or a boiler explosion. That's why operators must constantly monitor the water level. So next is controller failure indicators. So we have warning lights, erratic readings, unresponsive controls, unusual noises, and temperature/pressure fluctuations indicate potential controller malfunction. So um, when a controller begins failing, the boiler behaves unpredictably. The readings may bounce, controls stop responding, or alarms activate without reason. So these signs tell us the aut- automation can no longer be trusted and manual intervention might be needed. So next is our detection methods. So detection of water level and controller issue relies on gauge glasses, electronic sensors, alarms, pressure and temperature readings, feed water flow monitoring, operator observations, and clear communications of any abnormalities. Detection is mainly through sensors and alarms, but operators should also trust physical signs like vibration, sound changes, or inconsistent gauge movements. Early detection prevents any dangerous operating conditions. So, our immediate response procedures. So, low water level detection is our first. Identify warning signs of low water level through gauges, alarms, and visual indicators. Immediate recognition prevents catastrophic boiler failure. And our second is initial safety measures. Excuse me. Cease fuel supply immediately. Avoid adding water to overheated boilers. Alert all personnel in vicinity to potential danger. And our third one is controller failure response. So we switch to manual operation if possible, then document failure condition, implement backup control system according to manufacturer specification. And fourth is communication protocol. So alert supervision using emergency channels, provide clear status updates, follow chain of command for emergency response coordination. So, first step is recognizing the problem, and once detected, we must immediately shut off the fuel to stop heat buildup, and we should never add water suddenly because the hot tubes can burst. If the controller fails, shift to manual mode and report the event following the emergency chain of command. So, prevention and monitoring systems. So, let's start with water level monitoring system. So, continuous monitoring of boiler water levels using reliable sensors and gauges prevent dangerous low water conditions that could lead to equipment damage. These systems constantly track water level and trigger alarms when the water approaches danger. Reliable sensors prevent dry firing and protect the boiler from internal damage. So, second is pressure relief valves. Automatic valves releases excess pressure when predetermined thresholds are exceeded, preventing catastrophic failures in both low and high pressure boilers. When pressure rises too high, relief valves open automatically to not prevent, to protect the boiler. They act as safety escape for excess steam. So, without these valves, high pressure boilers would be extremely dangerous. Our third one is automated control systems. So, computerized systems monitor critical parameters and automatically adjust operations or trigger alarms when abnormal conditions are detected. So, automation helps maintain safe and stable boiler operations. However, when automation fails, operators must know how to switch to manual mode and maintain control of water level, fuel supply, and pressure. So, next is our second content is controller failure management. So, we have pressure sensor failures. Malfunction in pressure sensors can lead to incorrect readings, causing unsafe boiler operations and potential emergency situations requiring immediate shutdown. And next is temperature control failures. When temperature controllers fail, boilers may overheat or underheat, triggering safety concerns that require emergency response procedure. The next is water level controllers. Failure in water level monitoring systems presents critical risks of dry firing or flooding, necessitating immediate emergency intervention. So, um, each failure affects the boiler differently. A pressure sensor malfunction may give false readings, leading to unsafe conditions. And the next is temperature controller failure may cause overheating. And water level control failure is the most dangerous because it removes our main protection against dry firing. So the next is emergency shutdown protocols. So let's start with low water level response. So immediate shutdown protocol when water falls below critical levels includes alarm response, feed pump activation, and heat source isolation. So next is controller failure procedures. So sequential steps for manual operation. Sorry, during automated control failure covers backup systems, activation, and communication protocols. So the third one is low pressure boiler emergencies. Safety measures for pressure drops below operational thresholds includes system assessment, valve manipulation, and controlled shutdown sequence. And the fourth one is high pressure boiler protocols, emergency response for excessive pressure conditions, details pressure relief procedures, cooling methods, and evacuation guidelines. So these procedures follow strict steps. When water level drops, we shut down immediately. When controller fails, we activate backup systems and shift to manual. For pressure issues, we follow specific shutdown steps to prevent equipment damage. So the next is our manual operation, sorry, procedures. So overview of manual operations, essential procedures for operating boilers manually during emergency situations when automated system fails, ensuring continued safe operations. So the next is low water level response, step by step manual intervention procedures when water level drops below safe thresholds in both high and low pressure boilers. So we have controller failure protocols, emergency manual override procedures to implement when electronic or mechanical control systems malfunction in boiler operations. And we have safety valve management, proper techniques for manually operating safety valves, during emergency to prevent excessive pressure buildup and potential explosions. Manual operations is necessary when automated system fails. No? So operators must manual control feed water valves, fuel supply, and safety valves. Manual operation requires training also and calm decision makings during emergencies. So the next is the third content, which is controller failure management. So we have low pressure emergency response. Hang on. So immediate response protocol. Identify warning signs, shut down fuel supply, reduce system pressure, and activate emergency ventilations to prevent boiler damage during low pressure events. Next is water level restoration. Follow proper water addition procedures, maintaining minimum safe levels, and monitoring pressure gauges while addressing the root cause of water loss. Next is controller failure management. So switch to manual operation mode, implement backup control systems, and follow step by step troubleshooting procedures to restore automated functionality safety. So when pressure becomes too low, the boiler can collapse from thermal stress. The correct emergency response is to stabilize the unit and restore safe pressure gradually. So our immediate response procedures. So first one is immediate boiler shutdown procedure. So safely shut down high pressure boilers during emergencies by following the step-by-step protocols to prevent catastrophic failures and protect our personnel also. So the next is low water level response. So implement emergency measures when adding water level drop below critical thresholds to prevent overheating, tube damage, and potential explosions. So third one is controller failure protocol. Address automated control system failures by switching to manual operation and implementing backup systems to maintain safe pressure levels. And the fourth one is pressure relief valve activation. Understand when and how pressure relief systems activate during dangerous overpressure situations to prevent boiler rupture. So these immediate actions protect both equipment and crew. High pressure requires controlled shutdown. Low water needs to quick fuel cutoff. Controller failure means switching to manual mode, and overpressure activates relief valves to prevent rupture. And our next is pressure relief safety systems. So, number one, we have pressure relief valve fundamentals. Uh, Essential safety components that automatically release excess pressure to prevent equipment damage and protect personnel from dangerous boiler failures. And number two is high pressure protection systems, specialized relief mechanisms designed for high pressure boilers that activate when pressure exceeds safe operating thresholds. And number three is low pressure safety controls, systems that monitor and respond to inefficient pressure conditions, preventing collapse and thermal stress in boiler operations. And lastly is our emergency response protocols, step by step procedures for operators to follow during pressure related emergencies, including control failure scenarios and like you say, evacuation guidelines. So that ends my presentation. Thank you for listening. If you have any questions, I'll be happy to answer. Thank you.